These are the frequently asked questions for pre-calculus for section 2.8a1. And it says in exercises 1 through 6, determine the x values that cause the polynomial function to be a, 0, b, positive, and c, negative. So looking at number 6, we see that this one is already in factored form, which is great because then that just means a sign chart will take care of this. So we have the zeros. Looking at x plus 2, that's going to be a negative 2 as a 0. And it does help to know that this is a multiplicity of 3. We know it's going to cross at those points. This one, 4x squared plus 1 equals 0. Let's take a little closer look at that one. If we subtract 1, now we're dealing with a negative number. And we realize that this isn't going to have any solutions. These will be actually imaginary solutions when we take that square root. So those are not going on our sign chart. They're not useful to us. We are graphing in the real number system. And the last 0 here that we have is a 9, because 9 minus 9 will be 0. And that's a multiplicity of 4, which means that we're going to have a tangent. But what we really care about for the sign chart is the negative 2 and the 9. We want to know what's going on in the other positions. And if I don't use a graph, what I probably want to do is make sure that I put a couple of points on there to remind myself that is where it equals 0. So I can be careful if they want less than, greater than, not to use those points. Now, I think about my factors, and I have a negative 2. So I try putting a negative 3, something to the left of it in. If I put a negative 3 in this first set of parentheses, that would give me a negative 1 cubed, which will be negative. If I put a negative 3 into this one, it's going to get squared and it's going to be positive, so that set of parentheses is positive. If I put a negative 3 in this set of parentheses, they get raised to the 4th power, which is of course going to give me a positive. So negative is what's going to happen here. I have an odd number of negative signs. Between negative 2 and 9, great number to check out would be 0. If we put a 0 in here, it will be positive. If we put a 0 in here, that factor will be positive. I don't like my little plus there. And if we put a 0 in here, even though it'll be 0 minus 9, you're going to raise it to the 4th power, so it will be positive. So between negative 2 and 9 is going to be positive. Then to the right of 9, I would plug in a 10 and see what happens. A 10 in this parenthesis and that factor will give me a positive. A 10 in here will likewise give me a positive. And a 10 in here will get 1, 1 to the 4th, all going to be positive. So this stretch is also positive. Now, to take a peek at this, to just kind of get a sketch, we have a power of 3, a power of 2, and a power of 4. So that's a power of 9, which is, of course, going to be odd, which means that we are looking at an S-curve for this odd shape, which normally, because our leading coefficient would be positive here, we see as something like that. But we, of course, know there's going to be a lot of middle terms here, and we also know that it's definitely going to cross at negative 2 and at 9. Now, what else can we figure out from this? Well, multiplicity of 3, it was cutting through, but at the 9, we're bouncing. So if I venture a guess, and not, a guess, it's an educated guess, because it's going to cross at negative 2 and be positive, and this one is going to bounce, that will be the behavior of this graph. And sometimes that just helps that sign chart to take on a new meaning for you. So let's see what we have here. They wanted to know for A, when is it 0? Well, that's our negative 2 and 9. So at x equals negative 2 and x equals 9. For B, they wanted to know when is it positive. Well, that would be above the red line that I have up there. Wherever our graph is above that red line. And that's going to be from negative 2 to 9, but we can't include the negative 2 and the 9 because those are 0. And then from 9 on up. That's where our graph is above the x-axis. Again, we can't use this point or this point because that is 0. And then C, says when is it going to be negative? So that's our stretch of our graph here that is below the x-axis, and we don't want to use -2 because that is one of our zeros. So that will be negative infinity to -2. And that answers problem 6. Problem 18, pardon me, says solve the polynomial inequality graphically. So, you know me, I'm always going to try and factor first. I'd much rather do things by hand. I trust more when I'm doing by hand. And for this one, to factor it, what we would do is we'd try grouping. But the first thing I'd do is take a negative out of all of it and see if that doesn't help. But if we try factoring by grouping with this one, we'd pull an x out of both of those, and that would give us x plus 3, and then we have a problem. And that's because we have a 9x minus 4 in the back, and the only thing we could pull out of both of those would be 1. And we are not going to see that common factor all the way through there. So this one we really would be forced to grab the graphic calculator. So now, I have this one already in here, and I'm just going to hit zoom 6 and hope that we can see what we need to see, which is a 0. And there it is. Now, I'm tempted to blow this up between those x's, so let me go ahead and do that and just try a -2 to 2, just so this doesn't take so long for Blinky to tell us where it is that that 0 is located at. A few more pixels to work with here in that region. So second trace, number 2, and I want to get Blinky above and to the left and press enter, and then we're going to right arrow till he's below and to the right, and then enter through guess. And Blinky says we are at 0.388 approximately. All right, so here's what we saw graphically. Something like that. Now my concern would be there are 2 more zeros here because this was a 3rd degree polynomial. Where are they? Is this going to cross again? And the answer is no, because this was a negative 3rd degree polynomial. So we're not going to see another crossing over there. And of course you could use your sign changes to see that as well. But what we want to do is just use merely what we see here to answer the question, which is when are we less than 0? And that's this portion of the graph. And our x at this point was 0.388, which we cannot include because that was a 0. So our answer would be the 0.388 on to infinity. And that's because the green portion of our graph that's below the x-axis is what we are looking for. All right, nice little graphing calculator there. And then number 21, it says solve the following inequalities for the given function f of x. 21 we already have in factored form. We don't have a denominator, so we don't have to worry about asymptotes. But what we would do is think, okay, if I'm going to solve this one, oops, those are imaginary. I'm not going to get any real zeros out of that one. But 2x squared plus 3 equals 0. Let's check and see there. Subtract 3 from both sides. Oh, look at this one. This one's going to be imaginary also. So I'm not ending up with any real zeros there either. So just by trying that factoring piece, we see that we have a problem. But it's not really a problem. It's kind of a nice problem to have. And that is, this will always be positive. And when we look at it, we can see that. Whatever we put in, whether or not it's a negative or not, we're going to be squaring it, which makes it positive. So this is the situation where we realize that this is going to be an x to the 4th. Degree 4 polynomials are parabolic. So this one is apparently above the x-axis. And then we go through and we answer their questions. When is f of x greater than 0? Well, all the time it's above the x-axis. Remember, what we're looking for here is where are we above the x-axis when we talk about needing it to be greater than 0, And when they talk about it being equal to 0, that's hitting the x-axis, that's an x-intercept. And when we're talking about less than 0, that's going to be below the x-axis. So the entire thing, from negative infinity to infinity, is going to be greater than. B, greater than or equal to 0. Well, yeah, this is an or situation. We've got that covered. It's the exact same answer. And then C says, when will it be less than 0? None of our graph is less than 0. That's the empty set, the null set, no solutions. And then D says, when is it going to be less than or equal to 0? Well, we don't have any points that are equal to 0, nor do we have any points below the x-axis. So that one is the empty set also, the null set. All right, number 24. And as you see that these are grouped together, hopefully you're thinking, oh, well, these must all be special cases. There must be something goofy about number 24 as well. And you look at it and you realize, oh, yep, look at that. We've got a squared and a squared here. So we'll take a closer look at those zeros. But again, we see that this one is going to be imaginary. We're not going to get any out of that one. But this one does have a 0. We'd subtract 3. And then we would go ahead and divide by a -2. And we'd get x equals 3/2. So we could make a sign chart for this one. But again, what you want to do is think, okay, big blob right there, so I don't forget. It's touching. Right there is where it's touching. And then, if we make our sign chart, we realize that if I put in a number like 0, 0 squared plus 4 is positive. 3 minus 2 times 0, that's going to be positive. So positive times a positive, going to give a positive. And if we put a number like 2 into this, we're going to get a positive and a positive because this is squared. So here's the situation. This is a 4th degree polynomial, 3/2, and that power of 2, that multiplicity of 2 of 3/2 told me it was going to be a tangent. So we have 1 0 at that 3/2 position. And now we answer the questions. A says, when is f of x greater than 0? Well, everything but the 3/2. So negative infinity to 3/2, jump over the 3/2 and start again. Because 3/2 is exactly where it is 0, so we can't put that in there. For B, it says when is it greater than or equal to 0? Well, that's the whole thing. So that's negative infinity to infinity. All of it is greater than or equal to 0. C, when is f of x less than 0? Well, we look at our graph and there's nothing that goes below that sign chart, which I'm kind of using as my x-axis, my line y equals 0 there. So that's going to be the null set. And for D, when is it less than or equal to 0? Well, it's equal to 0 right here at 3/2. So a little set notation there of 3/2 or x equals 3/2, because that would be the only spot that we would be able to give them for 24, is that 3/2. 26, determine the real values of x that cause the function to be 0, undefined, positive, negative. All right, let's take a peek. Pardon me. So zeros, let's find those. That is when the numerator is equal to 0. So 2x minus 7 equals 0 and x plus 1 equals 0. That's going to be x equals 7/2 and x equals -1. When is it undefined? Those are our asymptotes, and those come from the denominator equaling 0, so x equals -5. We'll make that happen. And then we start talking about the sign changes for C and D. So go ahead and make our sign chart, and we need to put on there our zeros and our vertical asymptotes. So -5, -1, 7/2, and again, keep in mind, those are, well, the -5 is not a 0, it's an asymptote, but I'm going to put that piece on there to kind of remind myself that there's something special going on at that point. All right, now where to? Well, we go back up here, and we think, if I put a -6 into this, what's going to happen? Well, a -6 into this factor will give me a negative. A negative 6 in this factor would give me a negative. And a negative 6 down here would give me a negative. And we have 3 negatives, which will make this portion of the graph negative. Between negative 5 and negative 1, try negative 2. Negative 2 would give me a negative. Negative 2 here would give me a negative. Negative 2 would give me a positive in the denominator. And so now I have an even number of negatives, which makes that positive. Between negative 1 and 7/2, I would put a 0. If we put a 0 in here, this will be negative. A 0 in here will be positive. And a 0 down here will be positive. And we have an odd number of negatives, so that's going to be negative. 7/2 is 3.5, so maybe I put a 4 in. 2 times 4 minus 7, that's going to give me a positive this time around. And 4 plus 1 is 5, that's a positive. And 4 plus 5 is 9, which is also a positive. So this will be a positive down here. And again, you know, we could take it further and we could talk about where that vertical asymptote is going to be on the graph and all of that good stuff, but they didn't ask us to graph this. This is just tell us where everything is going to go. So for A, we already had our zeros. And for B, we already had our vertical asymptote. But now we want to go ahead and use that information to tell them when is this going to be positive. Well, it's going to be positive right here and right here. And so we start to think, okay, they said positive. They didn't say 0, so I need to leave the zeros out. So from negative 5 to negative 1, it'll be positive. And from my 7/2 to the right forever, this will be positive. And then D says, when is this going to be negative? Well, our negatives were here and here. And again, it doesn't say negative or 0, it says negative, so we can't include that vertical asymptote. So negative infinity to negative 5, not including the negative 5, and we can't include the negative 1 and the 7/2, but those are our endpoints that we're using with those open brackets. So that's the end of these FAQs.